Scenario: two students are asked to move a box from the ground level to the top of a loading dock platform, as shown in this figure. Student A pushes the box up an incline with negligible friction, which is the girl. Student B lifts the box straight up from the ground level to the loading dock platform, which is the male student. Question: in which case do the students do more work on the box, and why? Well, the answer is work is equal to the change in energy. Here, energy is conserved because it requires the same amount of energy to lift the box as it does to push the box up the ramp to the same position, ignoring any friction, of course. In both cases, the change in energy is actually the gain in gravitational potential, which is mgh. Here, both students are giving the same transfer to the gravitational potential of mgh. Therefore, the work done is the same for both students. The next question: in which case does the student apply a greater force? Now, the answer is while both methods require the same amount of energy, in the first part of the question, W equals to delta E, the force needed and the distance through which the force must be applied will actually vary. W is equal to the force times distance parallel. To lift the box will require a greater force because it is traveling a shorter distance. The distance, which is the height, is smaller, so distance goes down. So force has to go up. That is how you keep the work constant. However, if the girl, which is pushing it up the ramp, that is going to require less force because she's moving it up a greater distance. So notice that distance goes up, force has to go down to keep work the same. So this scenario, a lot of students believe that the girl is putting more energy into it. No, the girl is not putting more energy into it. They are putting the same amount of energy into the system. What is different is the amount of force they're applying. The boy, which is lifting it straight up, will require a greater force. However, the girl is going to require a less force if she's pushing it up the ramp. Okay? Make sure you are able to tell the difference in this scenario.